Okay, we are now looking at applications of our compound and double angles that we've just learned to apply to these questions. So if you recall, your double angle, your compound angles are your sine and your cos, your plus and your minuses, and it gives you those. This is on your formula sheet, and then you get your cos 2 alpha, or your cos double angle and your sine double angle. So we're going to refer back to that whenever we need and we see a double angle. Okay, so here we have B, C, and D are 3 points in the same horizontal plane, which means they're all on the floor, right? Such that BD is equal to CD. So now we end up having this guy over here equal to that guy over there. Okay, and automatically whenever we see that, we know that that's a triangle. We can assume that that angle is going to equal to that angle because they're opposite those sides, right? AB is perpendicular to the plane, which means it's probably a tree or a building or a person standing up on this floor, and that's where it meets this triangle and that triangle. And A is y degrees from C as at an angle of elevation. So we end up having this triangle over here and this triangle at the bottom. This triangle on the right hand side is not giving us any information to assist us in. Prove that AB, that perpendicular height, is 2d cos x tan y. So we want to find out in terms of the information that they've given us what that height is. We know we're going to work with this horizontal plane and we're going to work in this guy. Once we get into this guy, it's easy enough. That's a 90 degree. Therefore, this ends up being just your tan value again. But this guy is the one that we've got to figure out. And we need to find out where's their common side. So which one is the common side? Yeah, you're right. BC is the common side. BC is the value that we want to be able to solve for with the information in this bottom triangle to determine what AB's length is. So I'm going to draw out this bottom horizontal plane on the floor here or on the page here, just so that we can better see it and better understand it. Okay, so there's my triangle. The black is just the shape. I've labeled the angles 1, and I've written what they've given us in green. So here we can see that angle angle B1 is X. They've labeled it X. They've labeled BD small d and CD small d, and they've told us that this length is equal to that length. And because of that, we know that angles opposite equal sides are also equal. So what can we assume about angle C1? Well, it must be x2. Now, where is my common side? What is it that I want to know? I want to know what this is so that I can figure out what AB is. So if I look at this triangle over here, I end up having these two sides, those two angles. I don't have an angle including side, which means I don't want to use the cos rule. I want to use my sine rule. But for me to know CB, I need to know what angle D is. And I can figure out angle D. Well, awesome. I know that inside a triangle, every angle adds up to 180 degrees. And I then inferred that angle C is x. Therefore, I know that that is 180 minus 2x. And as soon as I see that, I think of something called reduction division. 180s, 90s, 270s, 360s will always give me reduction division. So let's go see how I can do this. I want to use my sine rule. What do I always write on the numerator? I always write the unknown first. So we're going to go CB or BC over sine D is equal to, and I can choose either side. It doesn't matter which side I'm choosing. I'm just going to choose any one of these sides. I'm going to go BD over sine C1. Now, I can't use x in this unless I've defined it. So firstly, I actually need to go define this. So I'm going to write here, before I even start this, guys, I'm going to write in triangle BCD, angle C1 is equal to angle B1, which is equal to x. And what is my reason for that? Well, my reason is that BD is equal to CD. BD is equal to CD. Equal angles opposite my equal sides. Okay? And then I can go figure out angle D1 by going 180 minus angle B and angle C, which is 2x. And my reason is sum of interior angles of a triangle. So now I've done that information. My teacher knows, okay, great, I know where she got the x from, and I know why she got the x, and I also know how she figured out, or you figured out, what D1 is. Now I can go and I can plug all of that in here. CB is what I'm trying to figure out, and I end up keeping CB by itself. BD I can replace with a D, and sine D1 is 180 minus 2x all over sine C1. And what is sine C? Sine x. Now I've got this, I can create a reduction formula from this. 180 minus, let's go see, let's look at our cost. You should know this off by heart. Cost, right? 180 minus 2. Which quadrant am I in? I'm in my sine quadrant, which means the 180 can fall away, and this can just become sine 2x. So that whole thing reduces down to sine 2x, a positive sine 2x, because it stays positive in that quadrant, over sine x. Now what ends up happening here is you guys all of a sudden go, oh, I've got sine, and I can cancel it, I'm left with a 2 there, and then you give me an answer of 2D. Guys, you cannot. You can only cancel trig ratios if the angles are the same. And in this case, sine 2x is like saying sine 2 times 30, which is sine 60 degrees, over sine 30. That's not the same. I cannot cancel these out. So let's go figure out how I can deal with that. Well, I know that this guy over here, let me circle him, my sine 2x ends up being a double angle. And how do I write a double angle? Let's go back to this over here. Do you see? Sine 2 alpha is 2 sine, or A, 2 sine A cos A. So I'm just going to go write 2 sine x cos x, because my letters are x's. So let's go back. Then we end up having CB is now equal to D times 2 sine x times cos x, all over, sorry, not the 2, sine x. Now what do we notice, guys? Now my sine x is the same, and it's all timesing at the top, so I can simplify, and I end up having 2d cos x. And is that not what they've asked me to solve? Prove that AB is equal to 2d cos x tan y? No, I've already proved CB. So now how do I get that to prove AB? AB, we know, is as a result of tan y is equal to, tan y is equal to opposite, which is AB, over adjacent, which is CB. This rearranges to AB is equal to CB times tan y. And I can change CB into that. 2D cos x times tan y. Now have I answered my question? 2D cos x tan y. Yes, that was quite easy to answer. Okay, pause the video, copy down the information, see if you can follow through with it again and try and understand before we go on to section B. Okay, now the misconception that learners have is when they get a question like this, they get very confused and then they can't do A and then they leave out B completely. Guys, please, B is purely a substituting question. It says, given that D is equal to 20 units, X is equal to 35 degrees, and Y is equal to 40 degrees, calculate AB correct to 2 decimal places. We now know the sizes of these values, which means all we're going to do is substitute them into this formula that has been given to you. So this might take up 4 or 5 marks. This might only be 2 or 3 marks at a maximum. Don't lose those 2 marks unnecessarily because you're not substituting in. So they told us that D ends up being 20 units. Cos x, they told us x is 35 degrees. And y is 40 degrees. You plug that into your calculator. So we plug that into our calculator. We're going to go, sorry, I'm just trying to figure out how to use my pen on this calculator. Okay, I'm back. So we end up plugging it in. It's 2 times 20. Let me just move it across so you guys can see the sum. 2 times 20 times cos 35 degrees, close the brackets, times tan 40 degrees, close the brackets. And you end up getting 27.4940713. They asked for 2 decimal places. 4 is below 5, so we keep it at 27.49. 27.49, and it's units. Sorry, they haven't given us the units that it's in. I hope you understood that. I hope you enjoyed it. I hope you can complete exercise 6.4 for me. That takes us to the end of this chapter. Girls, ask me any questions. Let me know if there's anything that you don't understand, and I'll gladly assist you. Please send me the picture with the question on a WhatsApp image, on our WhatsApp communication portal, and I'll gladly reply back there. Okay. Have a lovely day, girls. Study hard.